questions. Question number 1. Which of the following complex species is not expected to exhibit optical isomerism? See, this is the important question appeared in the recent 2013 IIT Advance. Now, see A, B, C, D. A is given as what? Dichlorobenzethyldiamine cobalt +1 complex, and B is triamine trichlorocobalt, and C diamine dichloroethylenediamine cobalt +3, and D is triethylenediamine cobalt +3 ion. These are the options given, and among these we have to choose whenever optical isomerism. Among the given options we have to check it which is a symmetric complex or unsymmetric complex generally exhibiting isomerism. Among the given options which is actually symmetric, we have to check it. Unsymmetric or optically active, symmetric are generally found to be optically inactive. So option B is given as what? CO NH3 taken thrice Cl3. This is the complex. So this is what we already discussed in optical isomerism, Ma3B3 type. Either you take Ma3B3, a cis isomer you take or trans isomer you take, they are all found to be what? Symmetric. We can cut into equal halves. So here the option B not expected to exhibit optical isomerism. Option B. So answer is here B. Question number 2. Which of the following ligand is quinquedentate? See, option A is given as what? EDTA -4, that is hexadentate. Option B is NTA, nitrilotriacetate. Nitrilotriacetate is what? Tetradentate. And HDMG is what? Only simply bidentate. And option D, HEDTA, that is what? Pentadentate. Quinquedentate means pentadentate. Monodentate, bidentate, tridentate, quadri means 4, quinque means 5. Quadri means 4, quinque means 5. Quinquedentate means what? Pentadentate. So option D here, HEDTA. HEDTA is the structure of this particular HEDTA. Out of 4 astates, 3 astates are there, 1 hydrogen is there. C double bond O minus, 1 is H, C double bond O minus. This is what? 1, 2, 3, 4, 5. These are what? HEDTA, pentadentate. Penta means quinque. Therefore, here answer D. Question number 3. With which of the following ligand NMO bonding is possible in metal complex? NMO bonding. See, A is what? Bipi. Bipi is actually carrying what? NN donor. That is symmetric. Both are NN donors. Coming to B, ACAC, acetyl acetonato. That is also what? Ovo donor. Coming to C, glycinato. This is what? GLY. You know the structure of this particular? Yes, already given to you clearly. This is what? NH2 and C double bond O minus. See, suppose the metal is there here, NMO. So here answer is what? C. Question number 4. EDTA ligand consists of. See, EDTA you know well. I said to you should practice this particular ligand is very important. In many ways it is appearing in different entrance exams. EDTA ligand consists of. What is actually EDTA? Ethylene diamine tetraostato. Recall if you write the structure of this particular EDTA. Structure of EDTA, ethylene diamine tetraostato. Ethylene diamond tetraostato. Option is 4 neutral donor atoms, 4 acidic donor atoms. Actually, it is having 6 donor atoms. In that, 4 neutral is at 4 acidic, 8 donor atoms it is coming. No, that is not correct. Coming to B, 2 neutral donor atoms and 2 acidic donor atoms. Actually, these are all what acidic donor atoms. These are all what neutral donor atoms. 4 acidic, 2 neutral. So option B is also not correct. Coming to C, 2 neutral donor atoms, 4 acidic donor atoms. Yes, this is neutral donor atom. This is neutral donor atom. 2 neutral donor atoms and 4 acetate groups are there. That is what 4 acidic donor atom. So then answer is what C. So it is carrying what 2 neutral donor atoms, 4 acidic donor atoms. Answer C. Coming to question number 5. The following is correct regarding MCO bond in a metal complex, metal carbonyls. Which of the following is correct for MCO bond in metal complexes? Option A is given as MC bond length is shorter than normal MC bond. See, generally we expect a MCO bond should be like this. Because carbonyl is what we consider what pi accepting ligand. Recollect while giving the classification of ligands, this particular CO ligand acts as what a pi accepting ligand. First, it donates a pair of electrons, results in the formation of sigma is set. Again, it accepts a pair of electron. Again, it accepts a pair of electron, results in the formation of what a pi bond. So, it is capable of forming a sigma and also what a pi bond. Therefore, metal to carbon and double bond formation taking place. We are expecting this type of bonding. No, generally because of its special character, it seems to be the pi accepting ligand. Therefore, metal to carbon, carbon to oxygen, this type of bonding is seen in the metal complexes. Therefore, option A is given as what? MC bond length is shorter. MC bond length is shorter than normal MC bond. And B, MC bond length is shorter than normal MC bond. Next, CO bond length is longer than normal CO bond length. See, here we are expecting single bond, here a double bond. Therefore, MC bond length is shorter. CO bond length we are expected triple bond, but it is double bond. So, it is becoming what? It is becoming what short? It is becoming what long. So, option A is correct. Coming to B, CO bond length is longer and than normal CO bond length. That is also correct. Coming to metal to carbon pi bond is D pi p pi bond. D pi p pi bond. Actually, this particular bonding is like this. It is actually donating a pair of electron, during the formation of a sigma bond. Again, the carbon atom is actually accepting a pair of electrons from the filled metal d orbital, resulting in the formation of a pi bond like this. This particular pi bond what we call d pi p pi bond. D pi p pi bond. So what option C, MC pi bond is d pi p pi bond is said. So option A is given as MC bond length is becoming shorter, CO bond length is becoming longer. That is correct. Coming to B, CO bond length is longer than normal CO bond length. Yes, it is also correct. And this particular metal to carbon pi bond is what? Pi bond is what is said? Metal to carbon pi bond is d pi p pi. Yes, it is d pi p pi. So all are the answers here. Answer is what? D. All are the correct answers. Terpa is a bidentate ligand, tetradentate ligand, tridentate ligand, and pentadentate ligand. What is terpi? Terpi you should know. This is what terpi. 3 pyridines are there fused together. Can you easily understand? This is the donor, donor. Terpi is a what type of ligand? Bidentate? No, it is carrying about 3 donor atoms. Coming to B, tetradentate? No, it is only tridentate. Therefore, option C is what correct answer. Terpi is what? Terpi is what it is a tridentate. Therefore, answer coming to be C. Coming to question number 7. COEN taken thrice plus complex, the ring size of COEN, ring size of CON. Option A 5-member ring, option B 6-member ring, option C 7-member ring, option D none of these. Let us see COEN, each ring let us take. COEN, CO3 diamine. This is 1, 2, 3, 4, 5. It is what simply 5-member ring. Therefore, answer is what A, 5-member ring. Nickel glycinate complex has 2 chelate rings. The ring size of each chelate ring is option A 4-member ring, option B 3-member ring, option C 5-member ring, option D 6-member ring. Let us see what answer now. Glycinate is it. Nickel glycinate. Glycinate ligand I am showing on the board. How it is linked to nickel. See, this is what glycinate ligand linked to nickel. So 1, 2, 3, 4, 5. It is also perfectly a 5-member ring. Therefore, 8th answer is what C. Glycinate ligand consists of option A neutral donor atom and acidic donor atom, 2 neutral donor atoms only, 2 acidic donor atoms only, and 2 basic donor atoms only. First, let us write the glycinate. See how the questions appear on ligands. Check it. Varieties of questions, different types of questions you are looking even on ligands. See, this is what neutral donor, this is what acidic donor. So, glycinate ligand consists of now a neutral donor atom and acidic donor atom only, a neutral and acidic. Therefore, answer is A. Next, coming to question number 10. COEN taken to SO4 plus the coordinate number of cobalt is. Option A is 4, B is 5, and C is 3, and D is none. Now we write the particular complex structure CO. EN taken twice. SO4. This is the part complex given. The coordinate number you have to check it. Yes. EN is what bidentate. 2 bidentates are there. 2 bidentates means 4 donor atoms. This is forming, these 2 ligands are forming 4 bonds with the cobalt. Coming to sulfate ligand, this is what bidentate generally. Therefore, it is forming 2 bonds. Total number of bonds around the cobalt coming to be what? 6. So, option A is given as 4, B is given as 5, C is given as 3, and D is none. Actually, the coordinate number of this particular complex is 6. Therefore, answer is D, none. Question number 11. Fe often taken thrice plus 2. The coordinate number of iron is option A is 2, B is what 3, C is 5, D is 6. These are the options given. First of all, you have to know what is particular ofen ligand. What is ofen? Orthophenanthrolene. Orthophenanthrolene. This is what we say ofen. Orthophenanthrolene ofen. This particular structure you should know. You know well, orthophenanthrolene ofen is a bidentate ligand. How many are there such ligands? 3. Each is carrying what 2 donor atoms. 3 ligands, therefore coordinate number coming to be 6. So, answer is D. Coming to question number 12. The complex is one is nickel DMG, the other one is nickel HDMG plus 2. The nickel oxidation number is 2 complexes are given. One is DMG twice. Second one is HDMG. Since this particular DMG what negative ligand, 2 negative ligands are there. comes to be nickel plus 2. And again nickel HDMG, yes, this is neutral ligand, but still it is carrying a plus 2 charge. In both of the complexes, nickel oxidation number is what? Plus 2. So option A is given as plus 2 plus 2, option B is plus 1 0, option C plus 2 plus 1, option D plus 2 plus 4. So in both of these complexes, nickel oxidation number coming to be plus 2. So answer A. Coming to question number 13. From which one of the complex 2 by 3 chlorides can be precipitated? 2 by 3 chlorides. 2 by 3. See, total there should be 3 chlorides. Out of those 3, 2 are precipitated. Then check the complex. A is CO hexamine Cl3. So all the 3 ligands are outside the complex. You are clearly observing. So that is giving rise to what? 3 chlorides are precipitate. Coming to the option number 2, that is what? B option. All the chlorides are inside. No chloride is precipitated. Coming to the option C, total chloride ligands are 4. Out of 4, 2 are outside, 2 are inside. Therefore, 2 by 4 chlorides it will come. And actually we want 2 by 3. Out of 3, 2 are precipitated. So coming to the option D, D is given as what? CO. CO NH taken 4, Cl2, single here, only single Cl, and outside is what? Cl2. See, how many total number of chlorides? 3 chlorides. Out of 3 chlorides, 2 are outside, 2 can be precipitated. This will definitely give a precipitation of what? 2 by 3 chlorides. So answer is what? D. Coming to question number 14. Question number 14. The number of particles that would form in aqueous solution from the complex CONH taken 4 times Cl3. So option A is given as 2 particles. Option B is what? 3 particles. Option C is what? 4 particles. Option D is what? 1 particle. What is the complex given? C, CO, NH taken 4 times Cl3 they are given. Total ligands are what? 7. The cobalt oxidation number coming to be plus 3. Since 3 chlorides are there, cobalt is plus 3. Cobalt maximum coordination number with plus 3 oxidation number coming to be 6. This complex we can write like this: CONH taken 4, Cl2, then outside 1. Number of particles Z, 1 chloride, 1 complex. How it ionizes? Number of particles means this is ionizing like this. If you are putting into water this particular, yes, we are putting into water, then CO NH taken 4 times Cl2 plus Cl minus. See, 1 particle and second particle, only 2 particle. So here answer is what? A. Answer A in this particular 14th question. Coming to question number 15, number of ions produced from the complex. Number of ions produced from the complex compound in its aqueous solution COCl3. Question number 15, what is given? COCl3, 3 and S3. For this particular number of ions produced from the complex, number of ions. So option A is given as 1, option B is 0, option C is what? 2. See how you write this particular complex formula. Actually, see here cobalt oxidation number coming to be plus 3. Why plus 3? 3 chlorides. Therefore, cobalt oxidation number plus 3. Whereas cobalt oxidation number plus 3, the total coordinate number coming to be 6. How many ligands are there? Yes, total of 6 ligands. All should be within the bracket. Now, if you write this chemical formula of the complex CO Cl3 NH3 taken thrice. This is the complex. What is the question actually? How many number of ions? There is no ion. It is actually neutral complex. So 0 ion. Answer is what? 0. Therefore answer is B. Question number 16. The number of ligands exhibit dual character for the Werner's formula of PT4NS3 Cl4. Dual character. Dual character means what I said according to Werner theory. The ligands which are actually satisfying primary valencies shown by dotted lines. The ligands which are actually satisfying only secondary valencies, they are shown by what? Solid lines. In some cases, some of the ligands are satisfying both primary and secondary valencies. Such ligand is shown by a dotted line and also by solid line. The ligand which is satisfying both primary and secondary is shown by dotted line and also by what? Solid line. Such ligand is exhibiting what? Dual character C. Now in this particular complex, what complex is given? C, PT, 4NS3, Cl4. But the oxidation number of platinum here plus 4. Plus 4 means quantity number of platinum plus 4 should be 6. How many amines are there? See 4. How many still you require? 2 more. 2 more ligands are required. Therefore, what you write? PT, actual complex formula taken 4 times, Cl2 and Cl2. This particular negative ligands are satisfying both. Here, negative ligands generally satisfy primary valence, but here they are inside the bracket and they are coming under coordination number. They are satisfying both primary and secondary. Such ligands what we call dual ligands. Therefore, out of 4 chloride ligands, 2 are actually satisfying both primary and secondary. They are inside the bracket, satisfying the coordination number even. Therefore, here answer is what? C, 2. The EN of platinum, NH taken 6 plus 4, EN of the complex. EN of the complex is PT, NS3 taken 6, NS taken 6 plus 4. Plus 4. So, option A is 86, option B is 84, option C is 85, option D is none. Generally, 3D elements gives a EN of the complex with 36, 4D with 54, 5D with 86. This is 5D element. Then still we have to check it, what actually it's a EAN. So, EN means what? Now, EN equal to atomic number of the metal ion. What is the atomic number? 78. Atomic number minus oxidation number. So, oxidation number is what? Plus 4. So, it is what? Minus. Plus 2 into coordination number 6. This is coming to be what? 86. EN of this particular complex is about 86. So, answer is A. Coming to question number 18. Which of the following does not obey EN rule? Does not obey EN rule. What do you understand by this? A complex which is not having the EN, the 36 or 54, 86, that is said to be not obeying the EN rule. Coming to option A, iron pentacarbonyl, iron pentacarbonyl, iron pentacarbonyl. Now, Fe, CO taken 5 times. This is what actually 26 plus 10. Yes, it is 36. Obeying. Option B, CO taken 6. CO taken 6. This is what? 24 plus 12, again 36. Obeying EN rule. Option C, it is Mn2 CO taken 10. Mn2 CO taken 10. It is what? A binuclear complex. This is what? 2 into 25, 50. 25, 50. Then 10 ligands, 10 into 20, 10 into 2, 20, coming to be 70. But wherever a binuclear complex is there, I said while teaching the EN, binuclear complex, metal one bond will be there. That we have to consider. 2 electrons still we have to add. 2 electrons for Mn bond. So, it is 72. You have to share to 2 metal atoms, therefore coming to be 36. Yes, obeying EN rule, 36, 36, 36. Coming to option D, what is given is CO taken 6, CO taken 6. Then atomic number of vanadium is 23. Since it is carbonyl complex, oxidation number coming to be 0. In all these, oxidation number is 0. Therefore, 23 plus 12 coming to be what? 35 only. So, this is a complex not obeying EAN rule. Therefore, the answer is what? D. Like this, you have to understand which is obeying EAN, which is not obeying EAN. Next question number 19. Question number 19. The unit of the complex is 54. It has 6 ligands. The metal ion is in +2 oxidation state. The atomic number of the metal atom is, he has given EAN and oxidation number of ligands also mentioned, and the question is we have to see what is the atomic number of the metal atom or metal ion. Now, option A is what? 42, option B is what? 43, option C is what? 44, and option D is what? None. Now, let us see according to the question what we know. EAN is equal to, yes, atomic number minus oxidation number plus 2 into coordination number. This is what equation to calculate EAN. What is given? EAN 54. Let us put EAN is 54 given. But what is asking? Atomic number not given, we have to calculate. What is the oxidation number mentioned? +2. Therefore, what it is? -2. Plus coordination number is said 6 ligands are there in the complex. 2 into 6. 2 into 6. Now, this is what 54. This is what 12 minus. Now, atomic number. This is what plus atomic number plus 10 it will be. 2 into 6 minus 2 plus 10. Then atomic number equal to 54 minus 10. Then answer coming to be what? 44. The atomic number coming to be 44. Here answer is C. Question number 20. The formula of the complex triethylene cobalt 3 sulfate is, option A is given as what? COEN taken thrice, SO4. Option B, COEN taken thrice, SO4 twice. Option C, COEN taken thrice, taken twice, SO4. COEN taken thrice, taken twice, SO4 also taken thrice. These are the options given. Now, see, option A is given as option B, option C, option D. Let us see now the last option only I write. CO, EN taken thrice, SO4 twice and thrice. Now, here you have to check what is the oxidation number of cobalt plus 3. So many sulfates are there? 3. 3 into -2, -6 charges. Total charges in the particular complex is what? 6. How many cobalts are there? 2 cobalts are there. Each should be -6 by 2 coming to be what? Plus 3. -6 by 2 coming to be what? Plus 3. Therefore, this is the COEN taken thrice, taken twice, SO4 taken thrice. The option D is the correct answer here for this particular question. Question number 21. Name the complex COEN NH2 taken twice, Cl2 plus. Question number 21. Name the complex. Let us see what is the complex given. CO, EN, NH2 twice, Cl2. This particular complex. Let us write by looking this particular complex. What is the name of the complex first? Now, diamine, dichloro, ethylene diamine, ethylene. Ethylene diamine, cobalt 3 ion, since there is a charge. Diamine, dichloro, ethylene diamine, cobalt 3 ion. This is the name of the complex. Let us check the options now. Coming to the first one, dichlorodiamine is said. You have to follow the alphabetical order. First diamine has to come. Coming to the B, dichlorodimine, ethylene-diamine and cobalt 3. Dichlorodimine is saying first amine has to come according to the alphabetical order. Coming to the option C, dichlorodimine, ethylene-diamine, cobalt 3 ion, and option D, diamine according to our naming, diamine, dichloro, ethylene-diamine, cobalt 3 ion. Therefore, this is the correct naming of this particular complex. So, answer is D. Coming to question number 22. Correct name of the complex, PDNS3H2O, C5H5N, NO2Cl. NO2Cl. This is the complex. Let us write the complex, let us name the complex before looking the options. PDNS3H2O, C5H5N, C5H5N, NO2. NO2Cl. NS3H2O, C5H5N, NO2Cl is the complex. Let us name the complex without looking at the options. Alphabetical order, let us take amine, aqua, nitro, pyridine, platinum 2 chloride. Platinum 2 chloride. Amine, aqua, nitro, pyridine, platinum 2 chloride. This is the actual correct name of the complex. Now let us check the options. Coming to the first one, nitropyridine, amine, aqua, platinum 2 chloride. First you have to follow the alphabetical order. Amine has to come. Coming to the option B, amine, aqua, nitropyridine, platinum 2 ion. Platinum 2 ion. Ion is said. Name, entire name is correct, but he said ion. Ion means there should be a charge over the complex. No charge. So coming to the option C, amine, aqua, nitropyridine, platinum 2 chloride. This is the correct naming of this particular complex. Therefore, answer is C. Next, coming to question number 23. Chemical formula of the complex potassium tetracyanone nucleate 0. I said, giving the name of the complex. From the name of the complex, you have to make it the formula of the complex. What is the name he has given? Potassium tetracyanone. Potassium tetracyanone nucleate 0 ion. Potassium tetracyanone nucleate 0 ion. Let us first write the formula of the complex. Next, let us see the options now. Potassium is said, let us write K, and nickel, tetracyanone. Yes, tetracyanone. What is said? Nucleate 0 is said. 0 means nickel, 4 negative charges are there. Nickel has to become 0, means there should be 4 cations outside. Therefore, it should be K4, NiCN taken 4 times should be the correct answer. Let us check the options now. A, K3 NiCN taken 4 times is, that will become nickel plus 1. Coming to the option B, that is K4 NiCN taken 4 times. This is the correct answer. Option B, answer is B. 24. Chemical formula of the complex ammonium hexaisothiocyanate chromate 3. Let us take the name. First write the formula. Let us check the options. That is good. Chemical formula of the complex ammonium hexaisothiocyanate. Ammonium hexaisothiocyanate chromate 3. Chromate 3. First let us write ammonium, NH4 we write. Next, hexaisothiocyanate, NCS, let me write. Hexa, chromium. Then we have to make it chromium 3. Chromium 3. How many negative ligands are there inside? 6. But chromium should be plus 3. There should be at least 3 cations outside the coordinate pair. The cations should be what? 3. Therefore, once you write ammonium 3, then ammonium, hexaisothiocyanate, chromate 3. Next, let us see the options. First option is NH4 taken twice is given. No, that is coming to be chromium plus 4. Coming to option B, NH4 taken 4 times, chromium NCS taken 6 is 3. Again in this, chromium gives to be, chromium oxidation number comes to be plus 2. Next option C, NH4 taken thrice, chromium NCS taken 6. This is the correct complex for the name given. This is the name, this is the formula of the complex. So here option C, so answer is C.